So here we have a graph of g of x. We're going to graph the inverse on the same grid. First of all, would you agree that the red graph is a function? If you did a vertical line going through it, you hit 1 point at a time. You never hit 2 points at a time. Now, when we go to do our inverse, what's going to happen is we're going to flip over this line. So we can draw the line, the dotted line, y equals x there. So we're going to imagine flipping that over that. The other thing we do algebraically is we just switch the x and the y values. So if we think of some of the points that we have, we have 3, 2. So now we're going to have 2, 3. We have 1, 3. So now we're going to have 3, 1. We have -1, -1. That point's not going to change. And we have -4, +4. So now we're going to have +4, -4. And when we go to graph it, if I just do the points, sometimes people join the points up in the wrong way. Okay, so we have to be careful. I started with this point, and then I went to this point. What does that mean here? I started with this one, and it would go to this one. Then the next point that it goes to is -1, 1. That would go down to there. And finally, over to there. Is that new graph a function? Is the blue one a function? No. It doesn't pass the vertical line test. Because if I draw a vertical line right here, you can see that it goes through 2 points. And in order for it to be a function, the vertical line can only go through 1 point, no matter where you move that vertical line. Now in your exams, sometimes they'll ask you to graph it on the same one. So we've graphed it separately. I'm also going to just look at what happens when I graph it on the same one. I'd have 2, 3, then 3, 1. That point stayed the same. And finally, that one over there. A couple of key things that I want to point out when you graph them on the same one. Notice that wherever you had points originally on the line y equals x, those points stay the same. That's where the two graphs intersect. Now if we do the domain and range of each, domain and range of the red one, well, it started at -4, and it went up to 3. So I'll do this one in interval notation. And the range started at -1 and went up to, biggest it gets is 4. Now when we do our domain and range of our blue graph, now the domain goes from -1 to 4, and our range goes from -4 to 3. So before we talked about an inverse being a reflection over the line y equals x. Algebraically, it switches the x and the y. Do you notice that the same thing, if your domain is your x values, if they all switch to y values, do you see that that equals the range of the blue one? And the range is your y values, they all switch to your x values, that becomes the domain of your inverse. So just like before, they're going to ask you this same question about inverses can be asked in a number of ways. They could ask you to, just to summarize here, They could ask you to reflect over y equals x. They could ask you to find the inverse. And we write in function notation the inverse with a little minus 1. So the question could ask you to find f inverse of x. All three of these things mean the same thing when we're solving. Questions you can do here are 4 and 9.